Welcome to part 17 of matrix and determinant series. In this section, we will see one question that can be solved through the application of three different topics. That's properties of inverse matrix, method for determining inverse of matrix, and multiplication of matrices. Let's dive into the question. If A inverse equal to this 3 by 3 matrix and matrix B equal to this 3 by 3 matrix, then what is A times B the whole inverse? The givens are A inverse and matrix B. If we need to multiply matrix A and matrix B, we have to find matrix A from the given A inverse. Even after finding matrix A and multiplying matrix A and matrix B, a such huge determination is waiting us. That's determining the inverse of matrix A times matrix B. In other words, this step is so lengthy and tedious. If we put property of inverse matrix in place, we can shorten the steps. So let's see the properties that help us to shorten the steps. We have this general formula. A times B the whole inverse equal to B inverse times A inverse. Just distribute the inverse to each matrix in bracket after switching them. We already have A inverse, and what is expected from us is to calculate B inverse. Again, from the properties of inverse matrix, we know that matrix B times identity matrix is always equal to identity matrix times inverse of matrix B. Hence, to apply this formula, let's form an augmented matrix and set matrix B to the left of the vertical bar and identity matrix to the right of the bar. It's advisable to follow step-by-step approach in order to convert each column of matrix B to the corresponding column of identity matrix. Let's start from column 1. To convert this negative 3 to 1, we have to multiply row 1 by the reciprocal of negative 3, that's negative 1 over 3. To convert this negative 10 to 0, we have to add it with positive 10. Let's focus on this negative 3 to generate positive 10. If we multiply negative 3 by negative 10 over 3, it will give us positive 10. So the formula that can convert this negative 10 to 0 is negative 10 over 3 times row 1 plus row 2. By the same analogy, if we multiply this negative 3 by 8 over 3, it will give us negative 8. Negative 8 plus positive 8 gives us 0. Thus, the formula that can convert this 8 to 0 is 8 over 3 times row 1 plus row 3. Multiplying row 1 elements by negative 1 over 3 gives us 1, negative 2 over 3, negative 1 over 3, negative 1 over 3, 0 and 0. When we apply negative 10 over 3 times row 1 plus row 2, we will find negative 10 over 3 times negative 3 gives us positive 10. Positive 10 plus negative 10 equal to 0. Negative 10 over 3 times 2 equal to negative 20 over 3. Negative 20 over 3 plus 5 gives us negative 5 over 3. Negative 10 over 3 times 1 gives us negative 10 over 3. Negative 10 over 3 plus 4 gives us 2 over 3. Negative 10 over 3 times 1 again gives us negative 10 over 3. Negative 10 over 3 plus 0 equal to negative 10 over 3. Negative 10 over 3 times 0 gives us 0. 0 plus 1 gives us 1. Negative 10 over 3 times 0 again gives us 0. 0 plus 0 gives us 0. Applying 8 over 3 times row 1 plus row 3 gives us 8 over 3 times negative 3 equal to negative 8. Negative 8 plus 8 equal to 0. 8 over 3 times 2 gives us 16 over 3. 16 over 3 plus negative 4 gives us 4 over 3. 8 over 3 times 1 gives us 8 over 3. 8 over 3 plus negative 3 gives us negative 1 over 3. 8 over 3 times 1 gives us 8 over 3. 8 over 3 plus 0 again gives us 8 over 3. 8 over 3 times 0 gives us 0. 0 plus 0 equal to 0. 8 over 3 times 0 equal to 0. 0 plus 1 equal to 1. Now, let's convert these three elements to the form similar to column 2 of identity matrix. To convert this negative 2 over 3 to 0, we have to add it with positive 2 over 3. If we multiply this 4 over 3 by 1 over 2, it will give us 2 over 3. Thus, we can use the formula 1 over 2 times row 3 plus row 1 to convert negative 2 over 3 to 0. To convert negative 5 over 3 to 1, multiply row 2 by the reciprocal of negative 5 over 3, that's negative 3 over 5. We have to add negative 4 over 3 to convert this 4 over 3 to 0. If we multiply this negative 5 over 3 by 4 over 5, it will give us negative 4 over 3. Thus, the formula that can convert 4 over 3 to 0 is 4 over 5 times row 2 plus row 3. Applying 1 over 2 times row 3 plus row 1 gives us 1 over 2 times 0 is 0. 0 plus 1 gives us 1. 1 over 2 times 4 over 3 gives us 2 over 3. 2 over 3 plus negative 2 over 3 equal to 0. 1 over 2 times negative 1 over 3 equal to negative 1 over 6. Negative 1 over 6 plus negative 1 over 3 gives us negative 1 over 2. 1 over 2 times 8 over 3 gives us 4 over 3. 4 over 3 plus negative 1 over 3 equal to 3 over 3, which gives us 1. 1 over 2 times 0 equal to 0. 0 plus 0 gives us 0. 1 over 2 times 1 gives us 1 over 2. 1 over 2 plus 0 equal to 1 over 2. Multiplying row 2 elements by negative 3 over 5 gives us 0, 1, negative 2 over 5, 2, negative 3 over 5, and 0. When we move to row 3, 4 over 5 times 0 equal to 0. 0 plus 0 gives us 0. 4 over 5 times negative 5 over 3 equal to negative 4 over 3. Negative 4 over 3 plus 4 over 3 equal to 0. 4 over 5 times 2 over 3 equal to 8 over 15. 8 over 15 plus negative 1 over 3 equal to 1 over 5. 4 over 5 times negative 10 over 3 equal to negative 8 over 3. Negative 8 over 3 plus 8 over 3 equal to 0. 4 over 5 times 1 gives us 4 over 5. 4 over 5 plus 0 equal to 4 over 5. 4 over 5 times 0 equal to 0. 0 plus 1 equal to 1. At last, let's convert this column 3 elements to the form similar to column 3 elements of identity matrix. Now, we have to anchor on row 3 to generate a formula for row 1 and row 2 because these first two elements are zeros. Hence, the addition and subtraction formulas we will generate don't convert these 4 elements to some unwanted numbers. To convert this negative 1 over 2 to 0, we have to add it with 1 over 2. If we multiply 1 over 5 by 5 over 2, it gives us 1 over 2. Thus, the formula that can convert this negative 1 over 2 to 0 is 5 over 2 times row 3 plus row 1. If we multiply 1 over 5 by 2, it gives us 2 over 5. 2 over 5 plus negative 2 over 5 equal to 0. So the formula that can convert this negative 2 over 5 to 0 is 2 times row 3 plus row 2. To convert this 1 over 5 to 1, we have to multiply row 3 by 5. 5 over 2 times 0 is 0. 0 plus 1 equal to 1. 5 over 2 times 0 is 0. 0 plus 0 gives us 0. 5 over 2 times 1 over 5 gives us 1 over 2. 1 over 2 plus negative 1 over 2 equal to 0. 5 over 2 times 0 is 0. 0 plus 1 equal to 1. 5 over 2 times 4 over 5 equal to 2. 2 plus 0 gives us 2. 5 over 2 times 1 is 5 over 2. 5 over 2 plus 1 over 2 means 6 over 2. 6 over 2 is 3. Applying 2 times row 3 plus row 2 gives us 2 times 0 is 0. 0 plus 0 equal to 0. 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 over 5 is 2 over 5. 2 over 5 plus negative 2 over 5 equal to 0. 2 times 0 is 0. 0 plus 2 gives us 2. 2 times 4 over 5 is 8 over 5. 8 over 5 plus negative 3 over 5 gives us 5 over 5, which is equal to 1. 2 times 1 is 2. 2 plus 0 is 2. Multiplying row 3 elements by 5 gives us 0, 0, 1, 0, 4, and 5. At this stage, the identity matrix comes from back to the front. Thus, the new matrix we found is B inverse, meaning B inverse is this 3 by 3 matrix. Then let's return to the formula and multiply B inverse and A inverse. B inverse times A inverse equal to, B inverse means this 3 by 3 matrix times A inverse means this 3 by 3 matrix. Both of them are 3 by 3 matrices, and hence multiplication is possible, and the result is also 3 by 3 matrix. To find the entry in first row, first column, multiply first row of B inverse with first column of A inverse. 1 times 1 plus 2 times 0 plus 3 times 4. To find the element in first row, second column, multiply first row of B inverse with second column of A inverse. 1 times 2 plus 2 times 2 plus 3 times 3. To find the entry in first row, third column, multiply first row of B inverse with third column of A inverse. 1 times 3 plus 2 times 1 plus 3 times 2. As you can see here, across a row, we multiply one row of the first matrix with each column of the second matrix. To find row 2, column 1 entry, we have to multiply row 2 of B inverse with column 1 of A inverse. 2 times 1 plus 1 times 0 plus 2 times 4. To find the entry in row 2, column 2, we have to multiply row 2 of B inverse with column 2 of A inverse. 2 times 2 plus 1 times 2 plus 2 times 3. To find the element in row 2, column 3, we have to multiply row 2 of B inverse with column 3 of A inverse. 2 times 3 plus 1 times 1 plus 2 times 2. To find row 3, column 1 entry, multiply row 3 of B inverse with column 1 of A inverse. 0 times 1 plus 4 times 0 plus 5 times 4. To determine row 3, column 2 entry, we have to multiply row 3 of B inverse with column 2 of A inverse. 0 times 2 plus 4 times 2 plus 5 times 3. To find the entry to be in row 3, column 3, we have to multiply row 3 of B inverse with column 3 of A inverse. 0 times 3 plus 4 times 1 plus 5 times 2. 1 times 1 is 1 plus 2 times 0 is 0 plus 3 times 4 is 12. 1 times 2 is 2 plus 2 times 2 is 4 plus 3 times 3 is 9. 1 times 3 is 3 plus 2 times 2 is 2 plus 3 times 2 is 6. 2 times 1 is 2 plus 1 times 0 is 0 plus 2 times 4 is 8. 2 times 2 is 4 plus 1 times 2 is 2 plus 2 times 3 is 6. 2 times 3 is 6 plus 1 times 1 is 1 plus 2 times 2 is 4. 0 times 1 is 0 plus 4 times 0 is 0 plus 5 times 4 is 20. 0 times 2 is 0 plus 4 times 2 is 8 plus 5 times 3 is 15. 0 times 3 is 0 plus 4 times 1 is 4 plus 5 times 2 is 10. 1 plus 0 plus 12 gives us 13. 2 plus 4 plus 9 gives us 15. 3 plus 2 plus 6 gives us 11. 2 plus 0 plus 8 gives us 10. 4 plus 2 plus 6 gives us 12. 6 plus 1 plus 4 gives us 11. 0 plus 0 plus 20 gives us 20. 0 plus 8 plus 15 gives us 23. 0 plus 4 plus 10 gives us 14. Therefore, A times B, the whole inverse, equal to this 3 by 3 matrix. By this, I wrap up this section. Hope you understand all the steps and the explanations clearly. If you have any doubts, don't hesitate to reach out to me. Please subscribe, like, and share the page. Stay safe.